To continue, um, let us have an example. So we are done with this actually. So I'm just going to give points of clarification on this matter. No, so you have here a car starts from rest and accelerates 10 meters per second squared for 4 seconds, after which it travels with constant velocity for 9 seconds. Then brakes are applied so that it decelerates at 5 meters per second. Find the total distance traveled by the car. Okay, so you have here, I'm going to draw the system. So I'm going to draw the system like this. So I'm going to use different notations. Say for example, I'm going to start here with x1. So that is where the car starts from rest. So you have here. So at this point, you have here v1 that is equal to 0 because it starts with at rest. Then it moves from x1 to x2. So I'm going to present the consistency of the variables as well as the subscripts. So it moves, no? So it travels with a constant for 4 seconds. So you have here 4 seconds. So that t, say I'm going to use the t that is from 1 to 2. So that is t1 to 2. So I'm going to use t1 2 is equal to 4 seconds. That t1 to there, it represents that the time required to travel from x1 to x2. So in here, I'm going to note here, this is now my velocity 2. Okay, so this is my v2. Okay, that is my v2. Now, if you look at the problems, you have here the acceleration. So a, I'm going to put here a, that is 1, 2. The acceleration from point 1 to point 2 is equivalent to 10 meters per second squared. So I'm trying to make a consistent presentation of the variables. Now, the car, after 4 seconds, it travels constant velocity. Constant velocity, so there's a change in velocity. And it travels from x2 to x3. And I'm going to name this one as my v3. Then acceleration. Acceleration is equal to 0. Acceleration from 2 to 3 is equal to 0. Why? Because velocity 2 is equal to velocity 3. Constant yung acceleration. So we have to consider this one. And then the travel, okay, from x2 to x3, I'm going to note this one as 2, then 2, then 3. t to 3 is equal to 9 seconds. Okay, so this 9 seconds. Then finally, the brakes were applied and it decelerated, no? And of course, it will come to stop, and let us name the stopping point, the position where it stopped as x4. And you have there the deceleration e, from 3 to 4, that is equal to negative 5 meters per second squared. Okay, so you have there. So we don't know the time. Time's not given, but we can have here the velocity 4, which is equal to 0 because it comes to stop. And please take note, okay, please take note the sign of velocity, a sign of acceleration. If the velocity goes in this direction, okay, and then the acceleration goes in this direction, okay, so a is positive. If the velocity goes in this direction. So this is the velocity, and you have here the velocity, I mean the acceleration. They goes in the same direction. We expect that A is positive. Okay, if we're going to have this one in the formula, though basically this both of these one because is actually negative going considering the direction. So this these are basically negative. How to do that? So this is basically negative if we're going to look into the direction. Now, another thing, if the velocity goes in this direction and your acceleration goes that direction, so your A is negative. Okay, so that's it. So this one, this means decelerating. Decelerate. So this is there is deceleration. This one is accelerating. So accelerating, but the direction is going to negative x, something like that. Okay. So going back to the problem, we have now this the problem, the picture of the problem. So we are going to start solving from x1 to x2. Okay, so we are given with the uh, values. Initial velocity v1 is equal to 0, then v2, that is basically unknown. Then we also have here the acceleration 1 2, that is 10 meters per second squared, then time which is equal to 4 seconds, and we're going to look for the x from 1 to 2. Okay, so the formula that we're going to use, of course, you're going to choose from the set of formulas presented a while ago. So I'm going to use, instead of x delta x, I'm going to use x 1 2. Then I can use this formula actually. This is 1, so I'm sorry, this is 1 times t, that is t plus 1 half, you have there a12 t squared. So velocity initial is 0, therefore this one is equal to 0. So we'll have 1 half times 10 meters per second squared times the square of t, which is 4 seconds, and square that quantity. You have 1 half 10 meters per second squared times 16 squared. So if you're going to compute that one, that is equivalent to 80 meters. So this is our x12. Okay. The next is computation from x to x3. So we have x2 to x3. Now, if you're going to look into the problem, the given is only the acceleration, the information acceleration, and v2 is equal to v3. So you have there this zero acceleration, then the time. So there is a lacking element here, so that we can compute for the distance. So with this, we all know that v2 is equal to v3 because acceleration is constant. So we can find v2. We can find v2 using the previous information from v1 to from x1 to x2. So finding v2, okay. So your v2 can be denoted, can be solved using the formula you have here. v2 is equal to v1 plus a12 t 1, 2. So you have there. Okay, so if you're going to plug in the values, this is equal to 0, right? So this is 1 equal to 0. Then you have here 10 meters per second squared times the t, which is 4 seconds. Then your v2 is equal to 40 meters per second. That is our v2, and we're going to use this one to compute, no, the delta x, or the x2 to 3. Okay, so with that, we are going to use the same formula. So instead of delta x, I'm going to use x23, which is equal to v 2 now. So you have now v2, then times time 2 3 plus 1 half. You have the acceleration, which is 0, right? e23 times t23 squared, and we all know that this part here is 0, acceleration is 0, therefore this becomes 0. So what remains is v2 times t23. So you have v, the velocity is 40 meters per second, times the time, which is 9 seconds. So we can cancel it out. So we'll have this is 360 meters. 360 meters, that is 4x to 3. So we have that one here. Now next is, of course, solving for the value of x3 to 4. So in solving x3 to 4, we are given with the following information. So v3 is equal to 40 meters per second. It is 40 meters per second because the velocity from v2 to v3 is the same. Then v4, that is equal to 0 because it will stop because you applied brakes. Then the acceleration is negative 5 meters per second squared. It is basically deceleration kasi opposing yung direction. Going papunta dito yung yung object, then the acceleration is pahina siya. So going on the other side, on the other direction. Then we now are going to compute x3 4. Okay, so using the formula, you were given with the velocity, final and initial, or v3, v4. Then you have here, then you have x. Then we can use this formula. So the final velocity, then v3 plus 2a 3 to 4 times x 3 to 4. Please take note of the notation. Okay? Pangit lang yung pagkakasulat. And we all know that this one is equal to 0 because it will stop. So we can take the additive inverse of this. Yeah. Take the additive inverse, so that becomes negative v squared 3 is equal to 2a34, that is acceleration, times x34. Then by rearranging the equation, or divide both sides by 2a34, 2a34, then we can cancel it out. So you have x34 is equal to negative v3 squared over 2 times a34. Then plugging in the values. Take note that you are not going to square this negative sign, only the value of v3, which is 40. Okay, so this is 40 meters per second, then square that quantity there. Then 2 times, take note that a34 is negative. So you have negative 5 meters per second squared. Okay. Then this is equivalent to negative 1600, 1600 meters squared. Cancel. how to do this. Keep. Going to keep this one. Okay, 1600. Then this is meters squared per second squared. Take note of the units. Then this is negative 10 meters per second squared. So we can cancel it out back. They have here meter, then that one there, then meter. And finally, that is equivalent to 160 meters. Okay, then since we are going to find the total distance, so we're just going to add total distance. Okay, so total distance is equal to x12 plus x23 plus x34. So just plug in the values. You have 80 meters plus 360 meters plus you have 160 meters, and that is equivalent to 600 meters. So this is the travel distance, no, of the um, vehicle or the car. Okay, so that's it. FN